Hi everyone, I'm Jung Hao, and today I will share with you 5 common mistakes for theory so you can prepare for your SPM. Let's start. Now the first mistake that I want to share with everybody is this thing called Archimedes principle. In Archimedes principle itself, there are a few smaller mistakes, so make sure you listen up. Now the first question usually in Archimedes is this thing where when they like to ask you, why is the ship able to float? So whenever we say something float, most common answers that everybody will write is they will say because there is this thing called the buoyant force. Now, but you have to understand, every object that is submerged in any fluid will have buoyant force. But why can it float? Float because the buoyant force is equals to what? Is equals to the weight. Now, weight of what? So we know buoyant force is also equals to the weight of fluid displaced due to Archimedes definition. But here you need to know that the buoyant force is equal to weight of ship, and that's the reason why it can float. Okay, now let's look here, second part. Now they like to ask you, in this case, the volume of seawater displaced by the ship. There is a trick question here. But however, this question there is a mistake. Can you change this to 1020 kg per meter cube? It's 1020, not 1.02. Now they give you the total mass of the ship and the cargo and without the load. So of course in this case, this object is loaded with merchandise. So obviously we need to use the one with cargo. So we know that weight is going to be equals to buoyant force, and everybody needs to remember, when we calculate weight, we need to know that kg, we will need to multiply by 9.81 to calculate out the weight. So that's why in this case, if this is 4.7, I'll write 4.7 times 10 to the power of 8 times 9.81 equals to 0g. Now I know that some of the students here will share this with me and say that, hey Jung Hao, the gravity and gravity will cut. Yes, I know. But there is a reason why I want you to see this properly. It's so that I can show everybody that when you change to weight, you need to multiply by 9.81. And in this case, this is the volume. Density of liquid will be 1020 kg per meter cube, and the gravity will be equivalent to another 9.81. So you can calculate out your volume by calculating the meter cube. Alright, this calculation you can do it yourself. We will go to the next part. Compare the volume of the portion of ship immersed in Mediterranean and in Sulu Sea. Now, biggest common thing that everybody will know how to do is that everybody will know how to do sea versus river. So if now I draw two similar boats whereby they are immersed in different liquid, so what you can see here is one is floating higher, one is floating lower. So let me ask you one question. Which one is Mediterranean Sea? Which one is Sulu Sea? So usually students will tell me, oh, this is sea, this is river. But this question is tricky because they are both sea. However, it says here, the density of the Mediterranean Sea is greater. So we are comparing different density. So if we compare this left picture and right picture, which one has higher density? I'll let you think for 5 seconds. 5, 4, 3, 2, 1. Okay, now the answer is this is the Mediterranean Sea, this is the Sulu Sea. Okay, why? Because every student will tell me that, Jung Hao, I know this is seawater because seawater will float higher. Then this is the river water because lower density, so it will sink more. Now, that's why we know that the left hand side being Mediterranean Sea having higher density, and this is Sulu Sea having lower density. Now guys, I have a question here. If they are both floating in Mediterranean like this and in Sulu Sea like this, okay, which sea will give more buoyant force? So which one will have more buoyant force? So which one has more buoyant force? Now the answer is the same, okay? Now, so when they both have same buoyant force, okay, what does it mean? Now, why is it same buoyant force? Because in this case, in both situations, the ship is floating, alright? Now, if they float, okay, what does it mean? It means that, let's say if this boat is 200 Newton in weight, it must have 200 Newton so that it can float. Now, no matter where the object is, as long as it floats, the weight has to be balanced with the buoyant force. Alright, so a very common misconception, the main common mistake here is people think that the higher the density for this floating object, the higher the buoyant force. It is not entirely true. Okay guys, why? Because they are both floating. So now we want to explain why is there a difference in volume submerged. Because they must have same buoyant force. So when the ship is in a higher density liquid, to produce equal buoyant force, it will need a lesser volume submerged because already high buoyant force ma. So therefore lesser volume lah. Sudah cukup to get you the buoyant force to float. But if you are in a liquid whereby it is less dense, so you start with low density, buoyant force must be the same. So if you have lower density, how? Never mind. You increase the volume submerged, so that the one that has lower density will have higher volume. The one that has higher density will have lower volume. So they will balance off to get back the same buoyant force. They will balance off to give you back the same buoyant force. So what you have to know here is, okay, kita tengok di sini ya. So we have to compare the volume and give a reason 2 marks. Let's just make this more interesting. Let's just make this to 3 marks. Alright. So the first part is, guys, for this video, I'm going to write short form. Otherwise, this video will take you at least an hour. So therefore, I want to cut this down to 30 minutes. So let's see how we can do this. So we'll say the volume of ship submerged, okay, of ship immersed in blah 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 blah, Mediterranean is lower than Sulu Sea. Teacher, can I write this sign? In exam, I don't recommend you to write this sign. I will suggest you write lower than Sulu Sea, lesser than Sulu Sea. Now, we have to start giving our reasoning, but first we can say something like, since the ship floats, the buoyant force is the same in both seas. Meaning to say that because it's floating, so it has to be the same buoyant force. Then baru, okay, so this is the first point, this is the second point. Then we can say, so therefore, as the density of the fluid, or in this case of the sea, increases, automatically the volume of ship immersed will decrease. Okay, meaning to say the higher density, the lower the volume submerged to produce the same buoyant force. Understand, right? Okay, so this is on the theory part for ships. Now, what if we have a hot air balloon? Now, the most tricky part is about this temperature of hot air balloon. Obviously, guys, it's called hot air balloon. So what do you think? The temperature, hot or cold? Definitely higher temperature. Alright. Now, so why do you need to know? Why do you need this hot air balloon to have higher temperature? Now, guys, everybody will tell me, so that the density inside decreases. But then I like to ask my students back the same question. So if you say lesser density, will it reduce the buoyant force? Because a lower density will reduce the buoyant force of the hot air balloon. So is this statement right or wrong? The answer is wrong, guys. It's wrong thinking. Why? Because when we look at buoyant force V rho G, this rho is not dependent on the inside of the balloon, but then this density is actually depending on the outside air, meaning to say that the buoyant force that acts on the hot air balloon is affected by the surrounding density. Buoyant force is not affected by the density of the air inside. So you change the air inside punya density, it will not affect the buoyant force. Then now my question is, if I change the density of the air inside the balloon, what will I change? Can you leave it in the comments below? I will reply you all. So my question is, if I change the density of air inside the hot air balloon, what will I change? What will I change? What will be my reasoning? Okay, check out the comments below. Now, so for this one, we are going to end here. Let's go to the second common mistake. Let's go. Now, the second common mistake brings us to this thing called the working principle of transformer. Now, So in the working principle of transformer, so you can see here we have a primary coil and a secondary coil. So this is where the secondary coil, input and output. Now, first question, why is it that if I draw a 2D picture, guys, if I draw a 2D picture, why is it that the current flowing in the primary coil can actually produce current in the secondary coil? So is it true that the current will flow across the core? Is it true that the current will fly across the core like that? Does it work? The answer is no, guys. It's not like that. Now, why? Because number one, the working principle of transformer is something what we call based on electromagnetic induction. Okay, so what is electromagnetic induction? So in electromagnetic induction, guys, this one SPM very likely. Electromagnetic induction is something to do with the cutting of magnetic flux. Tetapi the better way of saying cutting of magnetic flux is the change in magnetic flux. It's the same meaning, guys. Cutting of magnetic flux and change in magnetic flux is the same thing. Means that when you cut magnetic flux, when you切the magnetic flux, you will produce electricity, which is, we call this as induced EMF. Guys, we call this as induced EMF, which is voltage. Do you know that there is a video on EMF as well? It will be linked somewhere here. Okay, guys? So about what is EMF and potential difference. Okay, so if you are okay with this idea, so it is actually that in primary coil will actually produce something what we call a magnetic flux. Okay, so this green color is the magnetic field produced from the primary coil. So this primary coil will produce magnetic field or magnetic flux that will cut through the secondary coil, to give you voltage over here. So meaning to say that current doesn't flow in the core. We do not want current in the core. We want current in the side coil, not in the core. So the cutting of magnetic flux from here will give you induced voltage, induced EMF, which will allow induced current to flow. So in exam, what if they ask for the working principle of transformer? Now there are a few things you have to be very careful. The first one being, we say that we will always need an alternating current power supply to be connected to what? It has to be connected to the primary coil. So meaning to say that if you don't use alternating current, this thing transformer will not work because there's no continuous cutting. Meaning to say, if this is a coil, in order for here to have electricity, you must cut. Cut is an action. Okay, so meaning to say you need the current, you need the magnetic field to go in, go out, to go in, go out, go in, go out, go in, go out, go out. So therefore, it will cut repeatedly. So an alternating current is a current that will increase and decrease, which will give you a varying current to produce a varying magnetic field. This varying magnetic field will cut through the secondary coil. So we say alternating current connected to primary coil. The alternating current will produce a what? A constant changing magnetic flux. Okay, now constant changing magnetic flux. A lot of people say, yeah, Jung, how we got something called constant changing? God, if today you ask me what do I want to eat, I will say KFC, McDonald's, Burger King, A&W. So I'm constantly changing my mind. So constant changing magnetic flux means it will increase, decrease, increase, decrease, increase, decrease. So we can say that this changing magnetic flux will cut through the secondary coil continuously. Means it will continue to cut the secondary coil. So then only we can say the cutting of magnetic flux will produce your induced EMF, and and specifically, a lot of books will just write induced EMF. I prefer to write something more, I'll say, produce alternating induced EMF. To tell you that, I produce also alternating current, I muscle alternating current, I come up with alternating current. So the cutting of magnetic flux will produce alternating induced EMF, 其实是你的 voltage, and cause induced current to flow. Mana? In secondary coil. So we talk about you use alternating current. Alternating current can produce constant changing magnetic flux. The constant magnetic flux will cut the secondary coil. The cutting will produce your induced EMF in your secondary coil. Understand, guys? Okay, so if you got no problem, I'm going to give you a bonus section here. The bonus section is, guys, if you look at these four things, do you know what is this? This is about something what we call the efficiency of transformer. Meaning to say, how can we reduce the power loss or energy loss demand in transformer? Okay, we want more power to be sent over to the other side. Okay, so I'll use 3 minutes to talk about this. Now, in resistance of coil, because you use coil, right? Correct. So coil will have resistance. When your resistance is high, you will have more heat loss. Correct? Because the higher the resistance, more heat produced. So therefore, we want to reduce the heat loss because we want your power to be sent across this side. Your power to be sent across this side. So oleh itu, we want to increase the diameter of wire so that we can reduce the resistance of the wires. We are going to reduce the resistance of wires. Understand, guys? Increasing the diameter to reduce the resistance of wires so that we can reduce energy loss. What about hysteresis? Now, hysteresis is actually this thing whereby we also call this as the magnetism and demagnetism of the iron core. Okay, apakah this thing? Now, just now we mentioned this before, that we have an iron core, so therefore this thing, you don't want current to flow, but this orange colored iron core actually helps to produce more magnetic field. Something like it amplifies the primary coil to give you more magnetic field. Why? Because if your core can be magnetized, it will produce more magnetic field, so you will have more cutting. Good. More cutting means more electric lah. But your iron core very susah. Oops, sorry guys. Hang on ah. Okay, but your iron core very susah. Okay, why? Because your iron core will actually magnetize and demagnetize. Why? Because your current, if your current increase, then it magnetizes lah. Nanti your current decrease, then it demagnetizes lah. So this iron core will be magnetized, demagnetized constantly. So therefore, it wastes energy. Okay, it's like the car. If you keep on accelerating and braking and accelerating and braking, this is actually you waste petrol, right? If you can drive constantly, you will save petrol, right? So magnetism and demagnetism is like you step on the petrol, then brake, step, brake, right? Which will waste energy. Solution: use soft iron core. Now, if you use soft iron core, you actually use lesser energy to make the iron core to become a magnet. So meaning to say you save energy in the process. Okay. What about eddy current? Now, inside my iron core, guys, again, we come back to this iron core. So, should my iron core, this piece of iron core, should there be current flowing in the iron core? Yes or no? Of course no lah, guys. Because I want current in the coil. I want the current going out. I don't want the current to be inside. So this eddy current in core is actually bad because at the end it also produces a heating effect, which is no good lah. Solution: we use laminated core. How does a laminated core looks like? So a laminated core is actually like this, with sheets of metal between them, meaning to say they will use a sheet of metal, a piece of glue, metal glue, like how you laminate something with the plastic sheets. So that one is called laminated iron core, means I can reduce the current flowing in the core. Of course, what? Because you have more plastic and glue inside, less metal. Understand? Last but not least is on the leakage of magnetic flux. Now, how does leakage of magnetic flux work is this. Now, if I have a coil here, and I want to cut through the secondary coil, magnetic flux is produced in 360 degrees. Okay, so we see this magnetic field got cutting because it will go to the secondary coil. This magnetic field go out. So this one, and this one is being wasted because this magnetic field ends up going to the left, no cutting, end up going up, no cutting, ends up going down, no cutting. But this one goes through and cut through the secondary coil. So meaning to say you only use this side of the magnetic field. This is wasted. So wasted is also known as the leakage, leaked. So what is the solution here? Our solution is actually by winding the secondary coil on top of the primary coil. Okay, how does this, what does this look like? Okay, you all see So my primary coil will muscle this middle coil here and then go out. So this is my primary coil. My secondary coil will go around the outside like this. So if this is from the side, but if you see from the tengah, the orange color is inside, the pink color is outside. So no matter where your orange color primary coil sends the magnetic field, right, your outside pink color secondary coil is already ready 360 degree capture the magnetic field. So like this, right, you can use 100% all of the magnetic field without wasting. Faham, right? Okay, Ken? Alright, okay, if you got no problem, we're gonna go through the third common mistake. Let's go. We talk about Kepler's second law. In Kepler's second law, you have to understand that Kepler's law go by this thing called OAP. OAP stands for orbit, area, and period. Kepler's first law is called law of orbit. Kepler's second law is called area. Kepler's third law is called period. Now, so in Kepler's second law, there are three things that is very commonly being confused with. Number one is the orbital velocity. Number two is the orbital period. Okay, 1, 2, and the orbital area. Okay, so in velocity, period, and area, there are three things here. Which two is the same? Yang mana dua? Only 2个 is the same. Which one and which one? So the answer is your period and area the same, velocity is different. Meaning to say, just an example. So this is Earth. Earth goes around the sun 12 months because January to December. Okay, Ken? So misalnya A take 1 month, alright, to go from this to this, from P12 to P1. But just so you know, the time taken from P8 to P7 is also 1 month. That's why if you calculate here, there are a total of 12 months. Now, you will next see that, you see, their time frame is the same. The period of taken is the same. And if, according to Newton's second law, if you calculate this area, and if you calculate this area, both of this area will be the same. They will consist of the same area. Alright, so meaning to say that if you take same time frame, everybody will have same area. So meaning to say if 8 to 9 is also 1 month, they will also have same area. However, the speed will be different. Which one will be faster? Is it X here faster, or is it Y here faster? Now, the nearer you are to the sun, the higher the gravitational force, meaning to say that you will need a higher orbital velocity because you need a higher centripetal force. So therefore, to make this simple, X must have a higher speed, higher velocity of X is larger than Y. Common sense, right, guys? Y move so little, obviously Y very slow lah. X move so much, obviously X is much faster. Two people, the one that runs faster will always travel further. The one that runs slower will always be shorter. Can? So this is your third common mistake. For fourth common mistake, let's look at Pascal principle. Wow, guys, this one very interesting. Now, everybody knows that for Pascal principle, this is going to be oil, correct? Now, if you just look at this question, the answer to this question, now remember, it's U. But teacher, this one is boiling point. Yeah, this is the rate of boiling point. So boiling point, you want it to be high. But the rate of boiling point is low. What is the rate of boiling point, guys? Rate means it's like how fast. Do you want it to boil very fast? No, right? Correct. You don't want it to boil very fast. So the answer here is low rate of boiling point, so that it will not boil in short time, okay, in short period of time. So therefore it will not vaporize, or aka known as evaporate. Now we must remember, the lower the boiling point, okay, means it's easy to become gas, so it's easy to evaporate. The higher the boiling point, the longer it will remain as a liquid. But because of, guys, the word here rate, so this is a very, very confusing point. Rate means how fast. You want it to boil? Not. Don't want, right? So low rate of boiling point. Okay. Now, how do we explain why this must be small and why this must be big? Okay, guys, remember, this is a piston. Everybody in this class knows that. Obviously, we want a smaller to a bigger. In is small, out is big, correct? But do you know why, guys? Okay, the why is very simple. Now, so a lot of people will give the same answer. Oh, why small? So more force law. Why this must be big? So can lift heavier object law. You have more force and lift heavier object is the same meaning. But you cannot write this. It's not because it is same meaning, not because you cannot repeat your style, but it's because the reasoning is memang different. Okay. Now let's look at the what is the input and the output. Okay. Now first of all, we call this the master cylinder, and there is something called the second slave piston. So this is called the slave piston, although it sounds a bit weird. Now in your master piston, what do you push? You use force to push. So force is your in. What do you get? Output is your pressure, correct? So you use force, tekan, you get this pressure. The pressure will go over to the other side. On the right hand side, what do you supply it with? Pressure, aka known as your input. And the one that goes out is your force. You understand? So you use force, tekan inside, pressure the same. You guys know that this pressure and this pressure will be equal. That's why we will have the P equals to P. That's why F over A equals to F over A, kan? Right. Now, so therefore, in this case, if you tell me why this must be small, so I want to say, or I will use this sentence whereby I say, so that I can produce a higher pressure. So what do I want a higher pressure? To be transmitted equally. Okay, you want to transmit equally to the slave piston. So you want to produce a high pressure to be transmitted equally to the slave piston. Faham? Then what about this one? Okay, if you masuk pressure, keluar force, so you will say what? To produce more force. Okay, because now this is Y big already, right? So this small is this, right? Produce more force to lift heavier objects. So you nampak tak? This on the left hand side, I attack the pressure transmitted. On the right hand side, I say the force produced. So technically, this is how you should explain this whole entire thing, guys. Faham tak? Can alright. So this is our example, common mistake number 4. Let's go to our common mistake number 5. Now for number 5, electromagnetic wave. So guys, there is a video, I think it's in Mandarin, that about electromagnetic wave in my YouTube. You should have a look about it because it addresses everything on electromagnetic wave. So in electromagnetic wave, there is this thing called the Ryan, may I visit your ex-girlfriend. Now what is this? Now if you look at this, from left to right, your frequency actually increases, and from right to left, your wavelength actually increases. Now, how do we explain why we want higher frequency, why we want lower frequency or higher wavelength? Now, everybody, if you look at like notes or books, they will say, oh, high frequency, stronger, so can go further, okay? Now, guys must subscribe to KBAT Mathematics. I'll put the connection below. Now, so if you have a higher frequency, selain daripada we say it can go further, tetapi right, for higher wavelength, everybody will also say can go further. Okay, so siapa is the one that can go further now? Very headache. Now you must remember, higher frequency means higher penetrating power. If you got higher penetrating power, means it can, it can like tembus more things. So if it can tembus more things, meaning to say that this is the best thing to use in radar, guys. Radar. So radar, high chance to come out. Now for this radar, okay, you will be able to detect aeroplane. Okay, so radar uses, oh sorry, not gamma ray. Sorry, just in case I make this very confusing. It uses microwave. That's why you see, radar never use radio wave, although it's called a radar. Maybe last time radar started with radio wave because last time don't have aeroplane. But after that, when aeroplane starts to fly above clouds, above all the clouds, so you will realize that in order to scan the aeroplane above the clouds, they have to use the one with higher frequency, which is microwave. Tak mungkin gamma ray lah, later people kena radiation. Okay, can? Now, so this is comparing radio and micro. Now, what about radio wave? So a higher wavelength will actually give you a higher diffraction effect, guys. If you don't know what is diffraction effect, you should and you must go and read and study. What is diffraction effect? So diffraction effect is actually something to do with spreading of wave. Do you remember this thing? Like if we have a gap, so your wave datang, it will come out and split. So this is what we call the diffraction of waves. Now, if you have larger wavelength, you will have more diffraction. And more diffraction has what advantage? Your wave will spread out more. Meaning to say that you will have larger spreading of wave, means that your wave will spread out more. So which means that you will have better coverage. Okay. Now I want to say first, my student say, she says that if you want to teach student what is coverage, right? She says that you must say the mobile, this one has the very low wavelength because their coverage very bad. Okay, can. Now, so therefore, if you don't know, if you think which phone provider has the small wavelength, low diffraction, low coverage, you drop on the comments below. Let me see if I'm using the same phone provider or not. Okay. Now, so now obviously for Wi-Fi, do you care about penetrating power? You don't need to go to the sky, go everywhere, or do you care about coverage? Coverage means that, do you care about everywhere got the Wi-Fi? Okay, now for me, I care about my living room, my kitchen, my storeroom, my upstairs, downstairs, everywhere must have the wave, right? So if I want to have wave, I need my house to have more wave coverage. This is why for Wi-Fi, we will go for the larger wavelength, in this case, which is your radio wave. Okay, so why we can say a radio wave will have a larger wavelength so that the diffraction effect increases. Don't say go further, the diffraction effect goes further, more diffraction. So you can say more coverage Or if you don't want to say more coverage, you can say more spreading. So the wave is everywhere in the house. Higher position. Oh well, won't gonna block, right? If you put underneath the table will block the radiation. But if you put on top, the radiation will come down, then it will not block. It will not be blocked by surrounding stuff, correct? Now, more router antenna. Antenna is the tiang, right? Correct, guys? So the more antenna router you have, the more wave can be sent out simultaneously. Means that, let's say for example your house got 5 people, so there's 5 different antenna sending different information at the same time. Maybe one is to help your sister to watch Netflix, one guy will be for you to play game, one guy will be your mom watching Facebook video. So more antenna, more signal can be sent simultaneously. And lastly, 5 gigahertz. Then, at this point, there is a short confusion. Hey teacher, I thought you want higher wavelength. Why you pick high frequency? High frequency means, because frequency and wavelength is inverse one, right? So now you're choosing low wavelength pull-up. Okay, you are right. So this frequency and wavelength is actually quite confusing. Now, so in radio wave, there is a higher frequency radio wave which is 5 gigahertz and lower frequency radio wave which is 2.4. Now, so in 5 gigahertz, our house will also have 2.4 gigahertz. Okay, if you look at your phone, your computer now, you check, are you connected to the 5 or the 2.4? So 5 gigahertz has higher frequency, lower wavelength. So yes, technically 5 gigahertz in your house, a bit susah to get the connection. Especially if you're in the kitchen, especially you're outside the house, especially you're upstairs. But 5 gigahertz has another advantage. Technically, it is faster. Okay, why do we say it is faster? Now, by then you cannot write faster because faster will let the examiner think that you're trying to say the wave pergi cepat. You get what I mean? Like go faster. No. Internet faster means when you have higher frequency, frequency is information. Okay, waves per 1 second. So the definition for frequency is the number of complete oscillations made in 1 second. So a higher frequency means that more information / signal, okay, you can write more information, more signal, can be transmitted every second. So you see now, this is actually, I modify the frequency punya definition. So more information, more waves, or how many waves per second. So more information can be transmitted every second. Then you can tambah so that your internet, or you can say your internet connection is faster. Faham? Alright, can? Now, so therefore this is the 5th and final common mistake on the theory part. Now, I will be posting up 5 common mistakes on calculation, and on Monday to Tuesday morning, I will be posting something called the 10 must do questions before SPM on Wednesday. 10 must do questions. Now, all these questions I will take from the 2022 state paper. So therefore, if you have not done any state paper yet, don't worry, I will compile them, the 10 most important questions for you to do before your SPM. So if you guys got no problem, can you just drop me a like, subscribe to my YouTube channel, and thank you everyone. I'll see you in the next video.